what area we must finish today. Yeah. How was your weekend? Is it good? Did you
Okay.
all had a good time during the weekend? Yeah, a lot of people started to go out, isn't it? Right? Yeah. I was at Imago yesterday after lunch, and it was like so many people there. Like everybody's going out. And a lot of them brought babies with them, children, young children. I don't know, I feel scared when I see children out and about. Phobia, I guess, because it's 1 month, 1 year already. We've been going through this, what we call as MCO, right? This pandemic. Officially March, today's 1st of March. It's 1 year now. So what you see here, today's week 7, right? So as you can see here, week 7, we are to complete. Hey, hang on. Am I correct? Week 7?
Correct.
I am, right? Yeah. Yes, thank you. Yeah, we're going to finish up chapter. I hope I can finish it today. But if you look at week 8, we still have an allocation of perhaps I think 1 hour to do the chapter 4 as well. But yeah, I think I can finish it today. We'll see how it is. I can't finish it today, then we still have next week to finish up chapter 4, and then we'll start with chapter 5, the estimation and confidence interval. Now, for the diploma students, yeah, referring to the business students, they don't have this question in their final exam. But you guys, the degree students and also the diploma students, you would have to do this estimation and confidence interval. I have to keep on reminding myself because I tend to forget. Oh, yeah, very bad, huh? Okay, so now I'm checking out, or rather, to remind myself, when am I supposed to issue you your assignment? Yours will be on the week 9, so we have plenty of time. Because I was concerned here, you can see it's week 8, and we still have chapter 4 here. So just nice lah. Week 9 would be the day that I will be issuing your first assessment. Okay. So let me get the materials ready. I already double checked the notes, but I haven't checked on the form B. So give me a bit of time, and I hope you get ready your materials first. We're going to continue with binomial distribution. Oh yeah, the first test, the first assessment is a test, yeah. So definitely there would be a time limit for that. Only the second one, which is the assignment, which will be on week 11, would be the assignment. So a test, there is a time limit for you to do. Yeah, I thought it's both um, assignment. Apparently not. One of it is a test. So the first one on week 9 would be a test. Okay. So is there any question that you would like to ask me before I start the session for today? Any question, anybody? All good? Any question?
Good.
All good, is it? No question, yeah? So I'll start the recording, and we're going to start with the lecture. Yeah? Good morning, everyone. It's week 7, and we are here again today for our class BAMS 1613, Probabilities and Statistics. And we are still on chapter 4. Yeah. In last week, we covered the normal distribution. So that was a continuous distribution. Today, we're going to look at binomial distribution and also the Poisson distribution. Have I covered binomial distribution with you guys? Because I watched the last recording. I think I stopped here, yeah? Am I correct?
Oh, yeah.
Okay. Let me know if I've already covered it, yeah? So that I won't repeat the same thing. So binomial distribution, what is it about? It's more or less similar to the idea or the concept of the normal distribution, but it's just that when we're dealing with binomial distribution, we have certain characteristics that we have to consider. Yeah. The characteristics, also known as conditions, are what characteristics of the binomial that you should know, and by knowing all the characteristics, it's very easy for you to identify that the question is a binomial question or not. And a binomial distribution question, the question will not tell you, okay, this is a binomial distribution. No, not like the normal distribution. The normal distribution, on the question, the word normal is on the question, but not on binomial distribution. Yeah. So the first characteristic is there are n identical trials. Each trial has only 2 possible outcomes. Probabilities of the 2 outcomes remain constant, and the trials are independent. What does all this means? Yeah. Now the first one is that there are n identical trials. It means that for a binomial distribution, in the question it would be stated, yeah, that the same experiment is repeated to how many times. And we use the letter n here to indicate, the variable we use or the parameter we use to indicate how many times it is repeated. And it's all under identical condition. That means it's the same process. Giving you a very simple example, like when you throw a dice. Throwing a dice is very independent, meaning if you throw the first one, it has no effect on the second throw. So the process of throwing the dice can be done as many times as you want. It is identical conditions. It is a repeated process of the same experiment. And therefore, by identifying that in the question, that is the value of your n. Yeah. Again, as always, during my class, I would really appreciate it if there's any explanation that I'm doing and you're not sure what I've explained, please do ask. Either you can straight away turn on your microphone or you type on the chat, which I can, sometimes a bit late in checking it out, but I'll check it out. Now, the second condition is that each of the trial has only 2 possible outcomes. That means when we're doing a binomial question, you will identify from the question that there's 2 outcomes only, meaning yes, no, on, off, true, false, yeah, success, failure, yeah. So that means the outcome of that independent trials, yeah, the n identical trials, you can only have 2 outcomes, either success or failure, in such that I also have some other examples here, like situation good or bad, for item defective or non-defective, for company profit or loss. Yeah. or perhaps it's something to do with satisfying a certain event stated in that question. So basically, a binomial, you would be able to identify two outcomes from that particular experiment. Yeah, I hope that is clear. And then another characteristic is that the outcomes of the success and the failure, they are constant, meaning the value doesn't, changing all the time. It remains the same figure ever since you identify what is the probability of success. You say it's equal to P, then it's fixed all throughout the calculation. It will be fixed as zero. Let's say P, you say the value is 0.2, then your Q, probability of failure, would be 0.8. Yeah. So in this case, when we talk about binomial, the probabilities of the two outcomes, it remains constant in such that when you add the two probability, the probability of success plus with the probability of failure, you get the total value of 1. That's what we know in chapter 3. The total or the maximum value for a probability is the value of 1. And then we have the trials are independent, such that each of the trials, they are independent of each other. Just like the example I gave you just now about the dice, the throwing of the dice. You throw it the first time, it has no effect when you throw the second time. They are totally independent. The process of throwing the dice, it's independent of each other. So these are the four important characteristics of the binomial distribution. I hope you understand, my explanation about them. It's not that in the exam there would be any theory question asking you about, okay, what is the condition for binomial distribution like that? No. For binomial distribution, the question will never ask you to do any form of like theory kind of question. It's more on calculation. Yeah. So far, is it clear? Is it understood? Any question, Farah? Okay.
Okay.
Okay. Noel, I heard you respond. How about you, Calvin? Everything okay?
Okay.
Okay. All right. So if all is okay, did Calvin respond to me just now? Not sure.
No.
Well, anyway, let's look at the mode of calculation for binomial distribution. And if you have done this in AdMaths last time, you might be able to recall bits and pieces. Yeah. So let the random variable, depending on what question you are given, definitely there would be an indication of what the random variable is about. I mean, what the question is about. So first thing first is to write what your random variable is. So what you do is you just write the letter X equivalent to number of successes in n trials. Okay. And then we can say that X is having a binomial distribution with the parameters n and p. And in this case, we write it with this notation. X follows a binomial. B here stands for binomial. Some books you'll see it's written as BIN. Yeah, but I've used a B only here to indicate it's a binomial. And of course, in brackets, you have to write what is your parameter values. So we have n as the number of independent trials and the p, the probability of success. So in binomial, you only need to identify two parameters, that is the n and the p. But for the normal, if you recall what we learned last week, the parameters used are the mean and standard deviation. And when we already identify that X follows a binomial distribution, we are able to find exactly X successes That means the probability of successes of the x by using this formula. So we don't use a table to answer this, but we have to calculate it. And to calculate it, we have to use a scientific calculator. Yeah. And in this case, in order to find the answer, we have probability of x equals to x, meaning x here is the random variable equal to the value of the x that we want, and NCX. Now this, you need to use a scientific calculator. Yeah. And in your scientific calculator, what you see, I hope you are looking at your scientific calculator. Yeah. And what you see on your scientific calculator, the one that is colored brownish a bit, which you have to use the shift button, it is written as NCR on your calculator. Do you see that? My calculator, the version is FX570MS. It's a standard calculator that all SPM students are using. And if you look at your calculator, you should see the NCR directly below the AC button, the red button AC. You can see the division symbol, and directly above it, you can see slightly brownish, creamish, goldish color. It's written there as NCR. Okay, so in order to activate it, you have to press the shift. Yeah, so let me just, in case you have forgotten, let me just explain to you. Say I want to get 6 combination 2. Yeah, say my n is 6 and the x I want is 2. So how do you press it? You need to press the 6 verse, and then you press the shift button. Yeah. And then you press, of course, in my calculator, it's the divide button, which corresponds to the NCR. So check out your own calculator, because everybody, I don't know what version you're using, but I'm using Casio FX570MS. So identify where your NCR is, and then lastly you press the value 2, and then you press the equal sign. What do you get? Yes, exactly. Yeah. So Noel, did you get the same value?
Same.
Okay, good. How about you, Calvin? Did you try?
Oh, yeah.
Calvin, you got the same? Yeah, I hope you do. And therefore, that is how you calculate for this part, the NCR here, or the NCX, as what is written in the notes. Now, the P is corresponding to the value of P here. Oops, sorry. And of course, depending on what your X is, you make the P to the power of X and then multiply 1 minus P, yeah, to the power of N minus X. So this formula, if at first glance and you're using it for the first time, it may look, wow, complicated. But if you break it down and identify how you get each of the values, it is possible for you to calculate, yes or no? And of course, this particular, formula, it's important for you to know how to calculate it, because every semester, whether it's the final exam or the, for you guys, it's a test, definitely there will be a question on this. Okay, so I hope you understand how it is calculated. Now, another important thing concerning with binomial distribution, based on the parameters that we have, the n and the p, we can straight away get the value of the mean and the standard deviation. Remember, the value of the mean and standard deviation is used in the normal. So same case here, we can immediately get the value of the mean from a binomial distribution class, mind you, is just by multiplying the n times p. So whatever your n is and whatever your p is, if you multiply them, that is the value of the mean. And same goes for the variance. You can see variance is sigma squared is equal to n times p in brackets 1 minus p, or rather it's the q. So it's npq. And since the variance, this is the formula to get the standard deviation, you just have to square root it, square root the npq, and that is how you can get the standard deviation sigma. Okay, so this is how from a binomial distribution, we are able to get the values of the mean and the standard deviation. And hence, for any question on binomial, we can do approximation it to normal. Yeah, but I'll go into that as we go on. Right? Now, this is a simple example, example 6. If the probability of a defective bottle is 0.1. So you can see this question, probability of defective bottle. That means the bottle is broken. It's given to us as 0.1. Find the mean and standard deviation. Yeah, two things we need to find. For the distribution of defective bottles in the total of 400. So all these are information class. That means our n is 400. That is the number of, independent items. We have 400 defective bottles amounting to 400. So that gives us n equals to 400. And here stated also probability of a defective bottle is 0.1. This is our P. So since the question is asking for the mean and standard deviation, you just have to multiply it for the mean. That means n times P, 400 times 0.1, you get 40. And of course, the question also asks us to get the standard deviation. You just multiply. Oops, I didn't show it, is it? Or my animation is a bit haywire. Hang on, class. Oh, I didn't show it. Let me calculate manually then. So in this case, to find the standard deviation, which is indicated as, I just write it as SD. And that means the n times p times q. You have to square root all of it. Yeah, quite easy to calculate. That means 40, because that is n times p, and q is 0.9. And everything is square root. What is the answer that you get?
6.
Is it? Yes, correct. That is correct. The answer is a 6. Thank you for the answer. Yeah. I think I have missed it out. Yeah. I'm supposed to type it in. I remember. Yeah, now I remember I don't have the standard deviation. But this is the calculation class. So do take note how to calculate the mean and the standard deviation from any question. Yeah, of a binomial. Yeah.
Since there's a P there, where's the 0.1?
Oh, it's already, I'm using the 40, Noel.
Oh,
So that means it's the NP already. And the Q is the 0.9, right?
Oh.
So I straight away use the 40 there.
so the Q means what?
The Q is the 0.9 because Q is 1 minus P.
Oh,
Because P plus Q is equal to what?
1.
Correct. So we did just a bit of algebra there. So you know that the Q is 0.9. Is that clear? Okay, good. Yeah. So now we go on to example 7. Yeah. So any question yeah, that was good, Noel. If you have any question, just turn on your microphone. And Farah, I understand your microphone is broken. Yes, you can type in the chat and yeah, I'll respond to your question. So let's look at example 7 now. Now this is where you can see 20% of the bottle are defective, broken. Determine the probability that out of 4 bottles, that means this is our N. We have 4 bottles only chosen at random that, you know, will be defective. Yeah, 1 will be defective. That means this is our X. When it's stated here as 0, our X is equal to 0. So for this, first of all, we identify what is your N, given your N as 4, and your P is 0.2. How do we get the 0.2? From the 20%. Yeah. So from here, for the first question, X equals to 1, just like what I've written here. So what you do is you just need to put it into the formula. Now, don't forget, you see, this is the notation. X follows a binomial, whereby your N is 4 and your P is 0.2. So when the question asks to find the probability that, you know, only 1 that is defective. So 4 combination 1, because 4 is your N, your X is 1, 0.2 to the power of 1, and then multiply with 0.8 to the power of 4 minus 1. Yeah, so if you calculate this, what do you get? Just checking whether you can calculate it. What do you get?
Zero point four
Mhm.
096.
Yeah, 0.4096. Did you get the same? Yes. So I hope you do, because you need, if you cannot calculate using your calculator straight away, calculating all of it, then do it separately, class. Yeah, do it one by one and then multiply all of them. You should get 0.4096. Any question? Oh, thank you, Noel, for the answer as well. So the next one, if x equals to 0, you see the question B. So you just replace wherever the x is positioned at, you replace it with 0. The 4 is still the same, 0.2, which is your P, and your Q is 0.8. They are the same value. So you just put all the values in, and that would give you what answer? Same answer, is it? Did you calculate it? Now remember, 0.2 to the power 0 is the value of 1, yeah? And the only thing you need to calculate is 4 combination 0, which I think it's the value of 1. And then 0.8 to the power 3. And that should give you the same answer. Is it the same answer? Or did I calculate it wrong? Let me double check. 0.8 to the power of 3. And then times with 4 combination 0. Oh, then my answer is incorrect. It should be 0.512. Let me change it. It's 512. Okay, is that clear? Yeah. And question C, I hope that is clear. I hope you all know how to calculate it. Sarah, you okay? Okay, so putting the value for question C, you see at most 2 bottles will be defective. So at most, if you really understand the question, yeah, at most means the most is 2. The highest is 2. if the word at most 2 bottles. Yeah, we've done this in normal distribution. So if the question say at most 2 bottles, that means we only have to calculate 0, 1, and 2. So we have to add all these values here, the value of 0, plus with the value of 1, and plus with the value of 2. Now this is because of the question. It stated that we need to find the probability at most it is 2 bottles. It doesn't say at least 2 bottles. If at least 2 bottles, that means 2 and above. Yeah. But in this case, it says at most 2 bottles. That means up to 2 bottles only. Yeah. So in this case, we calculate 0 plus 1 plus 2. And since we already got the value 0 and the 1, you only need to calculate the value 2. Ooh, something wrong with my calculation, isn't it? Yeah, so can you give me a new value, please? Can you calculate for me? Because this one, obviously, we have 1 of that plus with 0.512. What is your final answer? Because obviously my answer is not correct. What is the answer then? Zero point. What is the answer, class? Oh, you can't get 1.0752. How come you come? It's a bit not correct. Is this answer 0.512 correct?
Yeah, the 0.
There's
Probably,
another.
probably 0 is correct. And then probability 1 correct, but probability 2 wrong.
Oh, the 0.1536.
Oh, yeah.
Can you calculate that for me? I can calculate it myself also. Hey, why my slide is so haywire? Hang on. The 0, this one is correct. 0.8 to the power of 3. Yeah, that is correct. 0.5. Then 0.1. Okay, so for 2, it's 4. Yeah, could be. Let me double check, yeah? Let me count as well. Give me a bit of time. For 2, 0.2 to the power of 2, and then times 0.8 to the power of 2. Okay. Because we cannot get more than 1. Yeah, Ferrer, Noel and Ferrer, it's impossible to get the value. Because these two are already calculated, it's correct. But only my 4 combination 2 is 6 times with 0.2 to the power of 2, and then times with 0.8 to the power of 2 as well. I got this one correct. 0.1536, that's correct.
Oh.
So plus with 0.512 plus with 0.4096. Hey, this is so impossible. What is wrong here, class? This is so wrong. At most, 2 bottles will be defective.
No, how do you get 0.1536?
Because 4 combination 2 is 6, right? Times 0.2
Square.
to the power 2, right?
Mm.
Then you times it, the next one is 0.8 to the power of 2, because 4 minus 2.
Oh, 4 minus 2. Oh, I thought 4 minus 1.
Because
So
it's x equals to 2, right?
Huh? But why x when x equals 0 is 4 minus 1? So,
yeah.
X equals to 0. Oh, this one, no. Oh dear, let me adjust it then. Oh dear.
and
A lot of typo errors. Sorry. Let me discard all this. This is not happening. This one is supposed to be 0.
oh, then
Then the value would be different, yeah?
okay already.
And then this one should be 4 minus 0, 0. It's 4. 0.8 to the power 4.
No. Never mind, I resolved. Okay already.
Oh, I must check out what is the problem here. So that means this is correct, class. Hang on, 4 combination 0 is 1. So that's why 2 times that. That means this is correct. And then, is it correct already? 2 times 0.4096, 0.1536. Correct about my answer. Oh gosh. It's just a typo of the 1 just now. Let me show you again. This is correct. Because it's x to the power, x equals to 0. So definitely 0.8 to the power of 4. So that's why I said it's the same answer. Yeah. So therefore, this is the correct answer. Yeah.
No.
This is the correct answer. Okay. Is that clear? It's just a matter of the 0 here, but I didn't or type it carelessly. I put it as 4 minus 1, the same as above, and I didn't change it. But the answer is correct already. Yeah. So since these 1 and 0, they are the same. So that's why I put 2 times 0.4096. And then plus with the x equals to 2 is 0.1536. Okay. Now this one, 0.1536, would be 4 combination 2, and then you type with 0.2 to the power of 2, and then same thing, 0.8 to the power of 4 minus 2. And that is how you get this. Try it out. Yeah? Did you get the same?
Yeah.
I already double checked and it's correct. Yeah. Sorry about that mix-up, class. Yeah, so sorry about that. I thought I got it incorrect earlier, but the slide is already correct as it is. It's just that here it's supposed to be the 0 instead of 1. I think that's why we had a different value. And yeah, you know how I know when you type the answer as 1.0752 just now, I know it's incorrect, because when we're doing probability distribution, you should never get a value more than 1. So that's why I noticed when you wrote the answer, you have the question mark on it also, Noel and Farah. So you realize it as well that it's impossible, right, to get a value more than 1. So that's good. That's good. Yeah. So now we have cleared this out. We go on to the next example. Okay. All ready?
Okay.
Okay. Noel, you said okay or hold on?
Okay.
Okay. Now we go on to the next example. This is about college student will graduate. The probability given to us is 0.4. And determine the probability that out of 5 students. So you see the question, it doesn't tell us that it is a binomial question. It just tells us what are the parameters. So you see the 5 here is your n and the 0.4 is your p. So from here, we know our random variable is about the number of students that will graduate out of the 5 students. So what we did here is basically we state the probability of success. This is our probability of success. And the 5 students is indicating to us what is our trial. Yeah, or how many is our trial, repeated trial. So we write the notation. X follows a binomial. Our n is 5 and our p is 0.4. And basically, this is the default formula. So we've done for none, meaning this is 0, right? For A, it means it's 0. X equals to 0. So practically what we do here is that we just have to put the same default formula, but only that the X is equal to 0. So help me to double check the answer, okay? So what you see here, I have n equals to 5, combination 0, and then 0.4 to the power of 0, and 0.6 to the power of 5 minus 0. Yeah, so when you calculate that, you get 0.07776, which I just put it into 4 decimal places. So class for A, it's simply x equals to 0. And same thing for B, x equals to 1. Yeah, so again, same process, put everything into the formula. You should get 0.2592. Please double check on the calculation. But for question C, it says at least 1. So it's different from the question just now. Just now was at most, yeah, at most 2. But here it says at least 1. At least 1 means 1 or more. And of course, since we only have 5 students, we only need to calculate until 5. So that means at least 1 means we are to calculate by adding 1, 2, 3, 4, and 5. Yeah, so this is the notation used for at least 1. So we're adding 1, 2, 3, 4 until 5. But the thing is, to calculate each one of these are very troublesome. I mean, it's a lot to calculate. So we do the complement method by using the total value 1. Because if you look here, the only value not included is the value 0. So it's easier to calculate by using 1 minus 0, which is x less than 1, is only one value, which is x equals to 0. So you just do this. You just 1 minus 0.0778. And that gives us the answer, which is much easier, don't you think? Yes?
Yeah.
Yeah. And the final question is, yeah, easier, isn't it, Farah? So all will graduate means all 5 will graduate because the total number of students is 5. So the only thing is to calculate x equals to 5. And that is how we get the solution. Okay? Any question, anybody? Any question? What if at least then 2? At least 2. At least 2 means, let me get my pen. It would be x at least 2, right? So it should be greater than 2. But then, meaning you have to add 2 3, 4, 5. The only thing you don't have is 1 and 2, 0 and 1. So you have to deduct these two. 1 minus x equals to 0 and x equals to 1. That is the two things that you have to deduct. Okay, Farah? Good question, Farah. Do you understand? Okay, good. Yeah. So yeah, that's how you solve it. So I think it's a good point to have a break because it's already 9:48. So we'll have a 10 minutes break before we continue with the next part. Is that okay?
Okay.
Okay.
Okay. Any question, by the way? No?
No.
Okay, so we'll continue after by 10 a.m. See you guys in a bit.
right, capital H for short, the number of heads from flipping a fair coin, we're going to assume it's a fair coin, from flipping coin 5 times. 5 times. And so like all random variables, this is taking particular outcomes and converting them into numbers. And this random variable, it could take on the value x equals 0, 1, 2, 3, 4, or 5. And what I want to do is figure out, well, what's the probability that this random variable takes on 0, can be 1, can be 2, can be 3, can be 4, can be 5. And so to do that, first let's think about how many possible outcomes are there from flipping a fair coin 5 times. So let's think about this. So let's write possible outcomes. Possible outcomes from 5 flips. From 5 flips. These aren't the possible outcomes for the random variable. This is literally the number of possible outcomes for flipping a coin 5 times. For example, one possible outcome could be tails, heads, tails, heads, tails. Another possible outcome could be heads, 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 tails, tails. That is one of the equally likely outcomes. That's another one of the equally likely outcomes. How many of these are there? Well, for each flip, you have two possibilities. So let's write this down. So so the first flip, there's 2 possibilities, times 2 for the second flip, times 2 for the third flip. Actually, let me not use the time notation. You might get confused with the random variable. Two possibilities for the first flip, 2 possibilities for the second flip, 2 possibilities for the third flip, 2 possibilities for the fourth flip, and then 2 possibilities for the fifth flip, or 2 to the 5th equally likely possibilities from flipping a coin 5 times, which of course is equal to 32. And so this is going to be helpful because for each of the values that the random variable can take on, we just have to think about, well, how many of these equally likely possibilities would result in the random variable taking on that value? And let's just delve into it to see what we're actually talking about. All right, and I'll do it in this light. Let me do it in, I'll start in blue. All right. So let's think about the probability that our random variable x is equal to 1. Well, actually, let me start with 0. The probability that our random variable x is equal to 0. So that would mean that you got no heads out of the 5 flips. Well, there's only one way, one out of the 32 equally likely possibilities that you get no. This right over here, 5 choose 0 is equal to 5 factorial over I try to fill out the whole thing. What's the probability that x, let me write that down, is equal to 2. And now I'll actually resort to, by the random choose, equal to 5. 5 times 2 is 10 seconds. There's a variable, these, factorial, 30 seconds. All right, 2 more to go. And I think you're going to start seeing a little bit of a symmetry here. 1, 5, 10, times 5 through this. 2. So I'll leave you there for this video. In the next video, we'll kind of graphically represent this and we'll see the probability distribution for this random variable.
Okay, welcome back. We are going to discuss about the normal approximation of binomial distribution. Hello, I hope everyone is here. Yeah. Okay. What is normal approximation of binomial distribution? Is that we use the normal approximation when the value of the n given to us is quite large, quite large, then when the n is very large, quite large, we have to do a normal distribution approximation, meaning we will do adjustment to the binomial distribution so that now the question will be a normal distribution. Now, how or what is the condition for us to be able to do so is that when your n is more than or equal to the value of 30, and when you multiply the n and p, it will be greater than or equal to 5. In fact, if you multiply with q as well, it will be greater than or equal to 5. So in this case, remember earlier, I did explain to you that a binomial, we can get the mean and the standard deviation. The mean is n times with the p, and the deviation is simply square root of npq, multiplying them. Or another way is it's the same, the np, then multiply with 1 minus p, because we know 1 minus p is basically the same as the value of q. So when we do this, for any binomial distribution, we approximate it to become a normal distribution. Then we have to consider correction for continuity. I normally call it as a continuity correction. So what is it about? The continuity correction is what you see in your notes. Is this such that depending on what value you are asked to find, so if the question in binomial, it asks you to find x equals to 2, since we did the approximation to normal, then the value, because in this case, we have a lot of scenarios or a lot of examples provided to you today. So you see x equals to 2 means since 2 is included in the calculation and it's equal to 2, then for normal, what we want to find is basically between 1.5 to 2.5. So basically what we did is we minus 0.5 on the left hand side, and on the right hand side we add 0.5. Because in binomial the question is asking for equal to 2. Therefore, if we did a continuity correction, then we have to find the range of values now adjusted to become 1.5 to 2.5. So same thing with the next one. If you look at it, x is in between 3 to 5 inclusive, because the 3 is also included. So it wouldn't be fair if you say you take 3.5. Since 3 is included, we should take a value, smaller than 3, which is 2.5. And then here as well, since 5 is included, you cannot take 4.5 because 5 is included. So in this case, we have to take 5.5. So now, if you did the adjustment from binomial to normal, now the value becomes 2.5 to 5.5. Okay. Now look here with the next example, though, you can see that it's x is greater than 3. No equal sign here. Now this indicates to us that 3 is not included. So since 3 is not included, therefore we take 3.5 to 5.5. Here 5.5, still 5.5 because it's still included. For the next example, though, we're doing the other way around. 5 is not included. It's less than 5. So therefore, it will be 2.5 to 4.5. And if both are not included, like you see here, 3 and 5 are not included because the x is less than 5, but it's more than 3. Therefore, what is more than 3 is 2.5 and 4.5. Is that clear, class? Any questions so far? Okay, quite clear, yeah? Because you need to identify whether the value is included or not. So if you see the next example, x is less than 4, that means the value 4 is not included. Therefore, when you do the approximation, it will be x is less than 3.5. But in this case, you see there's an equal sign. 4 is included. Since 4 is included, so we take 4.5. For the next example, x is greater than or equal to 4. Now, because of the equal to 4, 4 is included, and we want greater than. Yeah, x is greater than or equal to 4. So therefore, we take 3.5. Yeah, because 4 is included. But if x is greater than 4 only, that means this one, 4 is not included, we take 4.5. For cases when you have x is greater than or equal to 0, now take note there is the symbol equal here. So 0 is included in the calculation. For this kind, yeah, we take negative 0.5. If 0 is not included, then it will be x is greater than 0.5. And if you have x equals to 0, remember equal like the one that we did earlier here. So that means the value would be in between negative 0.5 to 0.5. So I hope this is clear in the manner how you would have to change a bit of the value of the x because of the continuity correction cases. Because this is, you have to consider whenever you change, or in a way what we call here is approximate, yeah, we have to consider any kind of very minimal error, yeah, or we call it as the standard error in the calculation. And because of that, that's why we have to do the continuity correction in a difference of 0.5 value. Okay, is that clear?
Oh, yeah.
Yeah.
Yes. Okay. Now from here, therefore, we have an example 10, and we are to find 200 tosses of a bias coin. It is bias, and that's why our probability of success, which is getting ahead, is 0.2. Because normally coin is getting a head or getting a tail. It is 50%, 50%. Yes or no? It should be 0.5, but well, this question, it says it's a bias coin. So n is very big. No. Oh yeah, our n is very big. It's 200. What the question is asking is that what is the probability less than 51 heads? So that this is our x, this is our n, and this is our p. So for this question, we have a random variable. That means this question is about tosses of a bias coin and getting a head. Yeah, so it follows basically a binomial. Your n is very big and your p is just a normal p. So in this case, since the n is more than 30, and if you multiply 200 and 0.2, the value is more than 5, isn't it? Because of that, we can use normal approximation. So just like what I said just now, since the n is equal to 200, which is more than 30, And when you multiply n times p, 200 times 0.5, you get 40, which is more than 5. So we do the normal approximation. So that's the condition that you need to check out from the question. Yeah. So from here, we have to do the normal approximation. What does it mean? It means you need to multiply n times p to get the mean, which is this, and square root of npq to give you the standard deviation. So now we have the value 40 as your mean, and standard deviation is 5.6569. Now I've put here to 4 decimal places, which a value which is what is encouraged for you to do in order to avoid any kind of error. Okay, so therefore the question is asking less than 51 heads. So this is what the question is asking. X is less than 51. But because we have approximate a binomial to a normal, we have to do continuity correction, meaning X is less than 51. 51 is not included. Therefore, continuity correction to it would be X is less than 50.5. So that's why you see here 50.5 you minus with 40, that is the mean, and divide by the standard deviation 5.6569. And notice that the X now I already do standardization to become a Z. So when you calculate this, 50.5 minus 40 divided by 5.6569, that will give you 1.86. So if you remember when we did normal distribution, normal distribution here, and 1.85 is a positive value, so it's on this side of the normal distribution, and we want everything less than. So what better way to solve this is using the complement method, meaning total area 1 minus with Z greater than 1.86. That means we deduct this small area that is not shaded. And when you deduct it, you check from the table, 1.86 is 0.0314, checking from the table. Therefore, what we get is 0.9686 as the answer. Is that clear, class? Any question?
No.
Okay. Okay. So moving forward. Now this is another example. Yeah. But this question, even though the cases that we have is only 10 tosses, and we want our X between 3 and 6 heads. Yeah. And it's a fair coin. But in this case, the question asks us to use the normal approximation to the binomial distribution. Even though it didn't state, you can see that the n is not more than 30, but we still do the normal approximation because of the question. Yeah. So here what we have is X is equivalent to tosses of a fair coin and getting ahead. So it follows the binomial. We have n equals to 10 and our p is equal to 0.5. Yeah. So if you do a binomial method, we want to calculate n equals to 3 and to 6, meaning you can add x equals to 3 plus 4 plus 5 plus 6, isn't it? But imagine that if you calculate that, you have to calculate 4 times of the binomial. But when we do it as a normal approximation, you can see immediately you can get the mean. N times p is 10 times 0.5. You get a 5. And the standard deviation is square root of npq. So 10 times 0.5 times 0.5. You get the standard deviation as 1.5811. So therefore, immediately we will have from the binomial approximated to become a normal, which is your n, your mu, sorry, is a 5, and your standard deviation is 1.5811. And hence, we don't have to do it 4 times, class. We just can calculate probability of 3 to 6 in between, inclusive. But because this is an approximation, you see, 3 is included because of the equal sign. 6 is included because of the equal sign. So we need to do continuity correction. That means what we want to find actually is probability of 2.5 to 6.5. Yeah, so remember, you must apply continuity correction if you do what do you call that? The approximation from a binomial to become a normal. So then we just have to minus the mean and the standard deviation, meaning we standardize it. Notice that the x now changes to become a z. Calculate the 2 sides of the values, and therefore you have a value between negative 1.58 to 0.95. So basically, if I draw the diagram, it would look like that. So we have negative 1.58, and here would be 0.95. All this area. That's what we want to find. And therefore, of course, a best way to solve something like this, which is in between, we have to use the total area 1 minus z greater than 1.58, because here is negative, right? So it's best to do the symmetrical process of it. So that's why I find probability of z greater than 1.58 and minus probability of z greater than 0.95, which is deducting the small area here. So when you calculate, check out the value from the table. You should get 0.7718 as the final answer. Okay, class?
Okay.
Yeah.
Okay. That's it. That's the normal distribution concerning with the approximation. So any question before we go to Poisson?
No.
No question. Okay, we go on to the Poisson distribution. Now, for Poisson distribution, it's quite easy to identify that it's a Poisson question because the word Poisson will definitely be on the question. Yeah, the word will tell us that the distribution follows a Poisson distribution. And the first characteristic or condition of a Poisson is that it must be a discrete variable. And the one thing that is different with the Poisson is that even though it's still independent, yeah, but most of the time when we're dealing with the Poisson, it is concerning with the time or space interval. Yeah. As you see here, it is always with respect to an interval, or it could be based on time, it could be based on space, or it could be based on volume. So for this Poisson, yeah, what we have to identify from the question is the value of the mean. That means in that question, it will tell you what is the average value, yeah, in a given interval of time, or it could be in space. And in this Poisson distribution, we use the lambda as our parameter, yeah, and your x, which is the random variable, is based on the number of occurrences in the given interval. and therefore it will follow a Poisson distribution, and it is based on this formula. So that means if I want to find probability of X, it's basically e to the power of negative lambda, whatever the value of your mean is, times with lambda to the power of X, and divide by X factorial. So the X is up to infinity because it's concerning with time. Time is unlimited, or even space, or even the volume value. So that's why our X, there is no limit. It's different from binomial. Like binomial, we have a fixed number of n, a fixed number of experiment. But in Poisson, there is not. We will continue. It's possible to continue until infinity. But of course, as we go towards a bigger value, the value becomes smaller and smaller. But all in all, if you add up all the values, it will give you maximum 1. Yeah, because it's still a Poisson distribution, a discrete distribution. So you see on the formula, there is the letter E. Now this again, I need you guys to check out your calculator. Check it out, and you can see it's red in color. That means you need to press the alpha on your calculator. That means every button on your calculator, there is one value, especially not the numbers value, the function value on your calculator, can see the E, yeah, not the gold or cream color E, but the red one. So you need to press the alpha here. Yeah, so if you want to try, yeah, you press the alpha and press the ln. It's on top of the ln, the ln, next to log. You see the E, the red color E there. But you must press the alpha and the E. And then you press the equal sign. You should get 2.7183 on your calculator. Did you get it?
Oh, yeah.
Yeah. So you must, especially for this chapter, yeah, class, I mean, this particular topic, you must use your scientific calculator, yeah, in order to get the values. If not, it's difficult to get the answer, yeah. And of course, the value of the lambda is the value of the mean or the expected value. So that's the only thing that you have to put it, yeah. The E is 2.7183, but it depends on to the power of negative lambda. It depends on the value of your lambda. And then the lambda to the power of x, depending on what is the x that you want to find. Yeah. So how do we use this? So let us look at the example. You can see x follows a Poisson, and P stands for Poisson, and lambda value. So lambda is the only parameter in Poisson. Yeah, so you should be able to differentiate between normal, binomial, and Poisson by now. So let's look at an example. A Poisson Poisson interval can be adjusted provided that the mean, which is the lambda, can be adjusted accordingly. So again, when we say adjusted, it's about approximation. That means for a Poisson, we can approximate it to become a normal. So a Poisson distribution, you can basically equate the mean, which is the same as the lambda, and the variance is simply sigma squared, is the same also as the lambda. Therefore, your standard deviation is the square root of the lambda. So you see, we can get the mean and standard deviation from the Poisson. That means we can approximate the Poisson to become a normal distribution. Okay, so this is an example. Yeah, but this one I'm not doing any approximation yet. And you can see the mean number of bacteria per milliliter of liquid is 4. That means our lambda is 4. But take note the interval, yeah, it's per milliliter. That means 1 milliliter, the mean is 4 bacteria. So you can see in the question also, the word Poisson is there. The question is asking, find the probability that in 1 milliliter of liquid, there will be no bacteria. That means your x equals to 0. 4 bacteria means your x equals to 4. Less than 3 bacteria means you have to calculate 0 plus 1 plus 2. Okay, so in order to answer this, as always, you must write x is equivalent to the number of bacteria per milliliter of a liquid, and therefore x follows a Poisson, whereby lambda is equal to 4. So in order to answer the first question, yeah, this is the default formula, x equals to 0. You notice here e to the power of negative 4 times with 4 to the power of 0 and divide by 0 factorial, just like the formula here. Now, can you try using your calculator? Do you get the same answer, 0.0183?
Oh yeah.
Yeah, okay. So this is how we solve it. Yeah, because quite straightforward. 0 bacteria is 0.0183. And then the second question is 4 bacteria, x equals to 4. So the only thing you need to change is the 0 here, yeah, which is the x here on the formula. So changing that, get 0.1954. Try it out, try the calculation if you get the same answer. Okay. Hello?
Yeah.
Okay, Kenna. Now the last question though, it stated at least at most 2, is it? Let me go back to the question. Less than 3 bacteria. So less than 3 means, you can see here, it's written as less than 3. That means we have to add 0 plus 1 plus 2. X equals to 0, x equals to 1, and x equals to 2. So you have to add all of this. We already calculated 0, which is 0.0183. You only need to calculate for x equals to 1 and x equals to 2. And that should give you all these values. Please double check for me. And the final answer is 0.2381.
Miss, if like
Yeah.
Poisson, is it possible like use the 1 minus something like that?
Not necessary. In this example, we don't have to do the one minus, yeah, because the question is only asking for less than 3. We can calculate it 1 by 1, and it's only 3. It's still considered small. If the question asks probability of x at least 3, it says at least 3. That means x is more than 3. Yeah, so at least 3 it says. That means then, because you cannot afford to calculate 4, 5, 6, 7, 8, 9, 10, right? I mean, at least 3 meaning got equal sign here. You are to calculate 3 plus 4 plus 5 until, as you know, a Poisson is until infinity, just like what is given here. So in this case, if the question is asking at least 3. Then you need to use 1 minus, yeah, x equals to 0. Then minus x equals to 1. And then minus again probability of x equals to 2. So this is still considered a bit to be calculated. So in this case, you have to use the value 1.
Oh. The E means what again?
The E. Which E? This E.
Oh, yeah.
It's the, from your scientific calculator, it's the exponential value, but you have to use the alpha to calculate it.
It's like, is there a name?
Mm,
Exponent.
yeah, we just call it as exponential value. It's a formula for the Poisson. It's an
Oh.
exponential value.
Okay.
Okay. Epsilon, they call it. Epsilon. That's what I
Oh.
was informed last time. Okay. Any question? No question? Okay. Then if no question, we move on to the next part. Oh, this is the final answer. Did you get the same 0.2381? You must practice yourself to calculate using this formula, okay? So that, you know, you'll be able to calculate it fast, especially for your tests. Yeah, because your test will definitely include this chapter, if I'm not mistaken. For your test, hey, hang on. I know your assignment is included, which is week 11, because your assignment, it covers from chapter 2 to chapter 5, your assignment in week 11. Week 9, I didn't list it out, but I remember it's from chapter 1 to chapter 4. Yeah. Any other question, class?
No.
Okay, so if there is no question, let's look at a different scenario. Now, this is slightly different. If you look at it, there is a change in the space, in the interval, or in the volume. Our question previously, it's concerning with 1 milliliter of a liquid, 1 milliliter only. But this time, this question is 3 milliliter. And if you look at question B, it's half of the milliliter. Yeah, so you can see a slightly different question. It asks for less than 2 bacteria, and the other one asks for more than 2 bacteria. So if you look here, for 3 milliliter of the liquid, notice that I'm using Y to indicate that now I'm not dealing with 1 milliliter, but I'm dealing with 3 milliliter of liquid. So that means my lambda now, I multiply it by 3, because our lambda is 4 actually. That's the value of the mean. That's the value of the average. So we times with 3, because now we have 3 milliliter. Now your lambda is 12. So we have a different notation now. That is Y follows a Poisson with the lambda equal to 12. So since the question asking less than 2 bacteria, so probability of Y less than 2, that means we only add 0 and 1. 2 is not included, yeah? So we just add these 2. And that means we apply to the formula. And calculating this, you should get 2 values, which is very, very long. And when you add them, you should get 0.0007897. Okay. And for the next question, which is a B, I'm using a different random variable. Now it's a Z, because now the quantity is reduced to 0.5 milliliter. So that means our lambda, we have to divide by 2. That's why our lambda is equal to 2. And since the question is asking more than 2 bacteria, that means I want to find out the value 3, 4, 5 until infinity. But we can't do that. It's until infinity. So the best way is to use 1 minus probability of Z equals to 0, minus 1, and minus 2. So this we can calculate. Yeah, meaning we just put all the values in with the correct lambda value, which is 2 in this example. So when you calculate all that, you should get 0.3233. Okay, class? Any question?
Why the lambda is 4?
Hmm?
Why 4? The lambda there.
This one?
Yeah, why 4 again?
Because this is based on the previous example. If
Oh,
you look
previous.
at previous,
Okay.
yes, it's the same question. Let me just show it here.
I saw that.
Yeah, okay. Any other question, anyone?
No.
Is it clear, everyone? Okay. All right. I'm glad everybody understand. Okay. Moving on. This is another case. The Poisson can be approximate to the binomial distribution. So just like the binomial, it was approximate to become normal. But this time we want to approximate a Poisson to a binomial. And therefore, a binomial, say we have n times p, it can be approximated to a Poisson. Or let me rephrase my words just now. The binomial is approximated to become a Poisson. Yeah. So when you have a binomial with the parameter n and p, it can be converted to become a Poisson, whereby the lambda is obtained by just multiplying the n times p. So then we can get the value in Poisson because we have created the lambda. Now this is only possible when the n is large and the p is small. So you see, binomial is very adaptable to any method, whether a binomial you want to solve it using a Poisson or you want to solve it using a normal. So it's possible to approximate a binomial to become a Poisson when your n is getting very big up to infinity and your probability value is very, very small. It's approaching 0. Yeah. So this is what can be done in such that the binomial distribution, as you can see here, is now approximated to a Poisson. Yeah. Now, if you look at example 14, we have eggs, which are 500 boxes. Eggs are packed in boxes of 500. Yeah. And I think one box is 500 eggs. Yeah. And on average, 0.8%. Now, do be careful about this. It's not 0.8. It's not 80%. Okay. It's 0.8. That means it's 0.0. 0.8 divided by 100 is 0.0. 8. Yeah, so we have that as the probability value. That's a small probability value. Yeah, so that is the amount that the eggs are found to be broken. So what we want to find is exactly 3, less than 3, more than 2 will be broken. So here, for example, for this example here, example 14, right? So what we do is we state the random variable x is basically about eggs that are found to be broken, and it follows the binomial n equals to 500, and our probability is 0.8 divided by 100. That would be 0.008. Oh, is that? I said 0.08 just now. Let me double check that. Must divide by 100. Oh yeah, it will be 0.008. Yeah, this is correct. And therefore, you can see the n is very big, the p is very small. Therefore, we convert it to become a Poisson, or approximate it to become a Poisson, whereby the lambda, you just multiply the n times p, and that gives you the value of 4. Yeah, so now it's easier to calculate. We want exactly 3. That means p, probability of x equals to 3. And therefore, what you have is just replace the value of 4 as your lambda, and x is 3. And you get the answer, 0.1954. Okay, and the other question is asking for less than 2. That means x is less than 2. So what is x equals to less than 2? What do we need to add? Class?
0 and 1.
0 and 1. So that's what we need to add, the 0 and the 1, and just calculate them, and that would give you 0.0916. Yeah, do double check my answer. And then the next one, more than 2 will be broken. We want more than 2, but as you know, of course, because we already decide to convert it to become a Poisson, so it will go on until infinity, isn't it? So because of that, we do the complement method. We use 1 minus x equals to 0, minus x equals to 1, and x equals to 2. So since we already got the 0 and the 1 here, yeah, and we only need to calculate the value of 2, x equals to 2. So deducting them, that would give us the value as 0.7619. Any question, class?
No.
No, just everything just same thing.
Yeah, it's almost, yeah, the same thing. It's just that you have to be careful with the calculation because it's involving with a lot of decimal places. But if you have understood the normal, you have understood the binomial, and you have understood the concept of Poisson, all these 3 distributions that we learned in chapter 4 are quite easy to do, as long as you follow correctly in terms of, do you need to approximate the question? Is the n very large or not? How about the p? And if you are able to identify all that, then it should be no problem. Okay, so I hope that is clear. For the next part though, this is normal approximation of the Poisson, because just now Poisson, now Poisson to normal. So if your Poisson is lambda, then we can get the mean, which is the mean is the lambda, And the variance is the square root of the lambda. So remember here, when we want the standard deviation for normal distribution, which is the sigma only, it means you have to square root the lambda. So the mean is just the same, but the standard deviation you have to square root it. So basically, for large lambda, especially for lambda that is very large, as you can see here, this example, this is your lambda, it's very large. Then we have to approximate it to normal, because it can get very tedious if you calculate it using the lambda equals to 30. The value is extremely weird. Very, very small value. Yeah, so in this case, it's best if your lambda is large, then you have to do approximation. But it's just that you have to be very careful with this value here. It's the variance, right? Remember, since beginning, I inform you about the normal. The value stated here is the variance. Therefore, if we use it for standard deviation, you have to square root, just like what I've written here. Yeah. So with that, yeah, you need the lambda. This is the condition. As long as the lambda is more than 20, you can do approximation of the Poisson to become a normal. Yeah. So this is an example 15 showing us that. So same thing, you see more than 23 calls, between 25 and 28 calls. So in this case, yeah, we have the parameter 30, that's your lambda, and given the space is 1 hour, yeah, that's our interval. So in order to solve this, our random variable is number of calls received by an office switchboard per hour. So our lambda is 30, quite big, yeah? So because of that, we approximate it to become a normal. And what you see here, the mean is 30 and the variance is 30. But remember, when we use it, we have to square it. So here, answering the first question, since we already approximated, we do continuity correction. We have x is greater than 23.5, because here we want x greater than 23. It is not including the 23, so we have 23.5, which you standardize it, same thing already. Yeah, 23.5 minus 30 divided by square root 30, and that gives us z greater than negative 1.19. And of course, because it's negative, you have to do the symmetrical method. So symmetrical it, we have 1 minus z greater than 1.19, and therefore you get 1 minus 0.1170. You need to use the table to calculate this class. Yeah, and hence you get 0.8830. Any question?
So the lambda must be greater than 20.
Correct. As
Oh.
long as the question is given to you, the lambda is greater than 20, then you can immediately consider a normal approximation to it. Because when your lambda is quite bigger, more than 20 or 20 in fact, it becomes tedious to calculate it, especially if you want to find a greater than 23. So for Poisson, you cannot calculate until greater than 23. That means 23 until infinity. And even though you do the complement method, how are you going to add from 0 to 1 minus 0, x equals to 0 until x equals to 23? Punya banyak to calculate, isn't it? So for lambda that is large, it's best you use a normal, which you only do one time, rather than doing the Poisson. It would be a crazy job. if you have a calculator and you already write the programming, the coding to do that, then it can calculate for you. But to do it manually, it's best to approximate it to a normal. Yeah, you understand?
Yeah. Not to
Okay.
memorize.
Okay. Yes. Memorize what, Noel?
Like which situation
Oh,
is the
yes,
normal.
correct. You are correct. Yeah. Like, well, the Poisson, if the lambda, the mean, the average is more than 20, convert. If your binomial, it's bigger than, how many was it? Well, your binomial is for your n very large and your p is very small. You have two options. Either you want to approximate it to normal or you want to approximate it to Poisson. Yeah, it's an option. But of course, you have to read the question, which method that the question asks you to approximate it to. Is it to Poisson or is it to normal? Okay. And for this question, there's another one which is between 25 and 28. Of course, if you use Poisson to calculate this, it's still possible because you just need to calculate 25, 26, 27, 28 to add them up. But since you already converted to or approximated to normal, since it's included, that's why we take 24.5 to 28.5. And therefore, from here, standardize it and do the same thing as what we've done last week. And you have two values. Not two values, I mean one value, but it's between the 0.27 to 0.1. Check out from the table of your normal distribution table, and that would give you 0.2349. Yeah. Is that clear?
Yeah.
Yeah. So normally class, when I have this in, these are extra examples, so I'm not going to touch into that. Normally in, how do you say? Normally in face-to-face kind of session, I would go through this very, very slowly because in class, I would expect students to calculate manually in front of me. Yeah, but doing online, we are able to do it quite fast. So my expectation from the three of you is please go through them, calculate them again, know the steps, how to get from this part to the next part. Some of you might be able to do it very quickly. Some parts you don't need to show, it's okay. But make sure you show this part where my pointer is. You see this part where you show the conversion of it until you get this value, until this. Maybe some of you don't want to show this, it's okay. Yeah, but basically this is a very clear, detailed or full working on the solution of this particular example. So even though you see I'm providing with you the solution, the final solution, like all this, I hope you do know and remember how to get 0.1170. It is from the table. So I expect from your own self, your own initiative to check it out and make sure you know how is it z greater than 1.19 becomes 0.1170. That one we did last week, and you guys should know how to do the calculation, yes or no? Yes?
Yeah.
Hello? Okay?
Yeah.
Okay.
Yeah. So, Calvin, any question from you?
No.
You're okay, huh? Farah, I believe you also have no question. Is it? Do you have any question, Farah? Okay. You have yep, that means a yes, and then no. It's like both yes and no, Farah? Well, I think I understand what you meant. Okay. So concerning with tomorrow's session, we have a tutorial. And I think I've already given you quite a few questions to do, yes or not? Yes.
Yeah.
Okay. So I have some extra question here. One of them is here. Yeah. And I want, is this available in your notes? Can you double confirm for me?
Chapter 4.
4.
No.
The last page. Check it out. Is it available?
Until the switchboard, office switchboard.
You mean the one we did here? This one, kan?
Oh yeah.
This is the switchboard. This is the last one that we discussed just now. You see this one? Yeah. Example 15 was the last one, I believe. So what I'm going to do, class, for this question, the extra example, I will give you guys on the WhatsApp, and then please do this question. There are several questions I'm going to share in the WhatsApp later, and then you guys need to prepare it for tomorrow's class, and we're going to discuss it together with the 5 questions. I think it was 5 questions that I asked you to do, yes or no?
Oh yeah.
Yeah, so that would be our discussion for tomorrow. So please do the question, and a few questions that I'm going to share in a bit, and I'm going to check the tutorial. If there's any question I want you to do there, check out your WhatsApp. Okay, so I'll see you tomorrow at what time tomorrow? 1 p.m. Yeah. Yes.
Oh yeah.
Okay, so I think that's all for today. Thank you, everyone. Have a nice day. Take care.
Thank you, Miss.
Okay, thank you. Bye-bye.